Hi everyone. We're going to be talking about geometric probability today. And in order to talk about geometric probability, we kind of have to understand a few things. Number one, we have to talk about probability. Now, remember we have talked about probability this year, and it's the total number of outcomes that you have. It's a fraction or a ratio of the total number of outcomes and the outcomes that make it true, or the positive outcomes. So the positive outcomes over the total outcomes gives you the probability that something will occur. Now, in order to do geometric probability, though, we kind of have to consider a couple of things. We have to consider segments because, remember, in geometry we have linear segments or lines, and then we also have to discuss two-dimensional figures because we also deal with two-dimensional figures. So first, let's look at this one-dimensional figure, a line. Suppose a point P on segment AB is selected at random. What is the probability that point P is on segment AC? So we're going to pick the whole thing, and so we want the probability that point P, is on AC. So that's how we would ask it. We want the probability that. All right, so first we have to consider what the whole length of AB is. That would be our total number of outcomes. If I pick a point anywhere on AB, it's going to depend on the length of AB. Okay, now remember, we write that by just writing AB. Okay, and then for it to be true, a positive outcome, it would mean that it has to be on AC. So it would be anywhere on the length of AC. And again, we write length as AC. Okay, so the probability that when you pick a point on AB that is on AC would be the length of AC over the length of AB. So that idea is when we're talking about one-dimensional figures, so segments, points. When we look at area or bigger figures, two-dimensional figures, we might have to consider area. So let's look at this one. So suppose a point P is picked at random in S. So this whole thing is S, and you can see R is inside S. What's the probability that it lies in R? All right, so again, now this is slightly different because it's two-dimensional, which means we're going to be dealing with area. So it would be the area that it's in R. Let me change that to black. All over the area in S, because S is my total possible outcomes, and true outcomes would be if it falls in the area of R. So that's when we look at things that involve area. All right, so let's put all of it together, and you have to kind of decide. So every 10 minutes, a bus pulls up to a hotel and waits for 2 minutes to let passengers get on and off, and then leaves. If a guest walks out of the hotel front door at any random time, what is the probability that a bus is there? All right, well, let's look at this 10-minute window because truly we really don't have to look at much more than that. So here we've got 10 minutes. I'm going to put it on a number line like that. So here's 0 and here's 10. So I know that my total possible outcomes that you could walk out the door would be, and there could be a bus there, would be between this 10-minute interval because the buses rotate every 10 minutes. So I know that my total possible outcomes is 10. It waits for 2 minutes. So let's think of it like this. This and this are the 2 minutes that they're there. So if you walk out within those 2 minutes, then the probability that the bus will be there would be true. So it would be 2 of 10 or 1/5. So you have a 1 in 5 probability that a bus will be there when you walk out the door. All right, so that was one dealing with segments. Let's look at area. So a person who is just beginning archery lessons misses the target frequently. And when a beginner hits the target, each spot is as likely to be hit as another. If a beginner shoots an arrow and it hits the target, what is the probability that the arrow hits the red bullseye? Okay, so the target's the whole thing, and then this is the bullseye. Actually, let me do it in red because they said the red bullseye. All right, so you can see that they've drawn in radiuses. This one's got a radius of 1, this circle's got a radius of 2, and this circle's got a radius of 3. So if they hit the target, that's the whole area, okay? So that would be my total possible outcomes, which would be 3 squared pi, which gives me 9 pi. Okay, making it true would be within that circle, which would be 1 squared pi. So 1 pi. Well, the pi's are going to simplify here to 1, and so the probability that I hit the bullseye is 1 in 9, so 1/9. All right, guys, so that's just a basic introduction to the two differences and the two techniques you're going to need to do geometric probability. We're going to do a couple examples tomorrow in class, okay? All right, talk to you soon. Bye.